Okay, so we now have the shortest program on Earth, the Hello World traditional program. It's a single line program, but we could always add another line. Real quick, we could just have a second command right after that, which is, let's see, we could do goodbye, cruel world. And then when we run it, it's going to think for a while because, again, we don't have to pay for these resources. And we get a syntax error. Again, as I said in an earlier one, syntax errors are our friend. It tells us that we have some problem with our syntax in line 2. I'm going to take a second, and you see it does the little squiggly lines under line 2 to tell us exactly where that is. Very convenient. I'm going to give you a second to take a look and see if you can see where that is in the program. It's a 2-line program, so debugging it shouldn't take that long. Hit pause for a second because I'll go a little crazy if I just sit here and burn cycles. So hit pause, take a look at the text, and see if you can figure out what's going wrong. Okay, I'll give you a hint. It isn't actually in the second line. This isn't uncommon for a syntax error like this. Really, it's caught the problem here, but the real problem is in the line before. And this is there's a point here, which is one of the most frustrating things to programmers who are just starting out, is that many of your syntax errors are just little errors that seem like they're inconsequential. It's a missing character. It's a slightly misspelled something. And we're so used to computers like Google, for example, fixing our small mistakes, realizing we've misspelled something. But there's no tolerance for error here. It has to be, the syntax at least has to be perfectly correct for it to be able to figure out what you're trying to say. All of this is very concise, and so it really needs all of those pieces. And if you look here, you'll see, let's take a look at the second line where it says there's an error, and we can take a look that we have a function here. The function is print. All functions have parentheses after them. That's one of the ways you can tell they're a function. So print, sometimes they just have an open parentheses, close parentheses, and that's it, because you're telling it to go do something as this function, like go make me a coffee. So it might be make me a coffee, open parens, close parens, and that's how you know it's a function. This one does pass, you give it some variables, some data to work with. And the data is the thing you want it to print in this case. And what we're giving it is a string. And this string has often what I would look for here is to make sure that I have an open quote and a close quote. If I forget the close quote, it's going to think the whole rest of the program is the quote and get confused. So I have the open quote and the close quote here. I have the open parens here and the close parens here. All of this looks to be good. Later on, we'll see that I'll make sure that, there aren't extra tabs or spaces in front of this, which will have an effect on it. So all of this looks good. And then when I look at the next line up, you'll see very quickly that this open parens is missing its mate, is unmarried. So we need to make sure that it's closing out properly. And now it'll work. So it does the first thing, and then it does the second thing. It prints this, and then it prints this. Simple enough. All programs have some kind of flow to them. And the most basic program is one that has a statement and then a statement. In this case, they've gotten crazy and had 3 statements. Statement after statement after statement. There actually are programs that just do that, where it's something that's very repetitive and it's very linear in the way that it works. For example, I have a program that goes out and backs up my kids' Minecraft server every night. So it runs automatically at midnight every night. It goes and it does step 1, open up a connection to the server. Step 2, download this file that's the world that they're working on. Step 3, rename it with the date so that we have an archive of it and store it on a different hard drive. So it's kind of just a step-by-step thing that it runs every time. But most programs will have some kind of flow to them, some kind of forking, as in this case, where it says, if this is true, do this thing, or don't do it. Or, for example, if it's false, do this thing, or don't do it. So it's kind of forking somewhere in the middle, and it does one thing or the other, depending on some set of conditions. This is called branching or selection. And a lot of programs, most programs in fact, have some loops in them or iteration where you kind of do something over and over and over again until it's done. So for example, I have a program that goes out and checks on my students, and it has to go through the whole list of students one by one and check to see if they've done something. So it'll go 1, 2, 3, going through a whole list of students until it's done. Then it'll drop out and be done with that part. In fact, many programs have loops inside of loops inside of loops. If you play video games, that whole video game is built inside of one large loop. Many programs and many applications, for example, that have user interfaces are built around this large loop. So we're going to talk a little bit about this part, the conditionals, the steps that it does only in certain cases. But before we do that, we're going to add in one more type of data, which is called Boolean, named after George Boole, who invented Boolean algebra. So Boolean variables, so we remember that this adds to the 3 that we've hit so far, which are integers, floats, and strings. Booleans are things that are true or not true, or things that are true or false, rather. So those are the only 2 conditions they can be. They can either be true or they can be false. So let's say, for example, we want to check to see whether people's names are long. I don't know why you would want to do this, but we could have a variable that was called long name, and we could say long name equals, let's see if I can make my keyboard work, equals true. So here we've assigned it, the variable's name is long name, and the condition there is true. If we then go and we ask about long name, it will, you know what it will do. This should not be a surprise to anyone. It will respond with true, right? Okay, so we can get rid of that for now. Now, what we're going to do here is we're going to have a conditional. If long name, then do this. And then, no matter what, you can say, you know, so what's this going to do? Take a look over it really quickly. Now it's actually, there's an error in it. It's an intentional error. And because of the way that the system colors it, it actually has given us an indication of what that error might be. But let's take a quick look at here what it's doing. It's saying if, that's a statement, a reserved statement. If long name, then do this. And no matter what, it's going to do this. It doesn't matter whether long name is true or false, it's going to do this. But if long name is true, it's going to print this as well. Now, as I said, I've introduced an error to this. And the error is that I've used apostrophes in here, and that's actually closing this out, right? It's confused. It actually points to right where the problem is, that it ends that string literal right here when we really want it to keep going. Now, there's a couple of ways we can solve this. There's the easy way and the hard way, I guess you could say. I'm going to do it the easy way for now. There's another way we can fix this, but for now, remember, we can use either single quotes or double quotes to do a string. This is a good reason you might want to use double quotes. Now, the truth is, within a string, you might have single quotes and double quotes in there, in which case this won't work. So there's another way you can do that, and that is to put a backslash in there. And so that's the other possibility. We could put backslashes in there right in front of it. We could do both of those. You'll see that those won't print when we print. So that's another way we can kind of make sure that that doesn't work. If we do the backslashes in there, you'll see if we put the single quotes back in, it's not going to have the same problem it had before. They're all going to be the right color because those don't close out the string in the same way. When you put the backslash in front there, it makes it so that it treats this as a character instead of the end of the string. So it's just a tricky way to be able to include those in the string you're using. Again, it's one of those things that often comes up as an error, and you might not, especially when it's not code coloring this way, you might not see why it is that that's not working, right? Okay, so let's go ahead and run this. All right, that's a long name you've got there. Thanks for asking. So the reason it's printed this is because this condition is true. If we change this to false, right? And we rerun it. It's going to skip this part because it's not true, right? And it's just going to do this part. So in this condition is something that resolves, that ends up being true or false. Now it's pretty rare that you'd have a variable like this where it's actually a variable that contains a true or a false. It's more likely you'd have something like if, so for example, we could do it this way. Let's add in a new variable, which is my name. And we'll do my name. Oops, let's see if we can spell. So if my name, so if you'll recall, we have something called len my name, right? Len is len is a function that returns the length of something. So that's going to return the number of characters that are in this string in this case, right? So if len my name is more than, what's a long name? More than 10 characters? 19 is super long. If len my name is more than 10, then it's a long name. Let's try that one. We actually don't need this line anymore. I can get rid of it, right? That's a long name you've got there. Thanks for asking. So in this case, this part is true. Len my name is over 10. So we have a condition there. If I say 5, let's do this, equals 5, is that true? Let's see what happens here. So this is a callback to recall that this is not actually equals. Remember, it's an assignment. It's the wrong one. And it's, again, an error that people make over and over and over again. So what we want to say here is actually if 5 equals, because that says if these two are equivalent, then print that. So what's going to happen now? It's going to say that's a long name you've got there. But we know that 5 is not equal to 4, right? So in this case, it'll skip it because that's not true. It's false. If 5 is more than 4 and we run it, that's now going to resolve to true. But if 5 is less than 4, last time I checked, it is not, so it will skip that. Okay. Let's do this. If 5 is less than 4, print that's a long name you've got there. Let's do what we had before, which is let's actually check the length of the name. Actually, I'm going to leave that there for a second. If len my name. So this is a little bit tricky because it's one that people can fall into pretty easily. This is going to return a number, not a true or a false, right? Now, as programming practice, it's a bad idea to do this. There's conditions under which you might do that, but it's trying to take an integer in this case and make it into true or false. So it's the same as saying if 15, right? I don't know how many characters there are there, but if 15, and it's going to say yes, this is true. How about if 1? That's also true. How about if 0? Now, this differs by programming language. In this case, it says 0 is false. But that's a really kind of messy thing to do, and generally you don't want to do that. So you want it to be something that resolves very cleanly as either true or false. So we'll go for one that resolves that way, len my name, rather than just having it len my name. We'll say if len my name is more than 20. Honestly, I probably should have figured out what the length of my name is, but it's obviously not more than 20 because it didn't do that. Now, what if we wanted to do, if you remember, there's this one where it says, if it's true, it does something. If it's false, it does the other. Let's have it do that. So ifs can also have else's, and I'm going to do Shift Tab to bring me back to the core, else, print, and we'll do a quick that. I don't want to deal with that again. A reasonable length. Okay, so Now, if it's more than 20, it's going to say that's a long name you've got there. If it's less than or equal to 20, it's going to say, in other words, if this statement is false, it's going to go and do this. That's a reasonable, then that's a reasonable length. Okay, so a couple of things to note here. It's going to be one or the other in this case, right? It's either going to be this one or this one. And you'll note that this is unique to Python, that there's indentations here. And what it says is that if this is true, do everything under that indentation. So I can add something else. I can have it do a second line, for example. You should change it. And that's not going to do anything right now, obviously, because my name isn't long enough. But if we make it 10 instead, it will do that, both of those things in there, right? So it'll do everything that's indented. And then when you're done with the part that's the if part, you bounce back out and say else. And then this is all the stuff it does in the case other than that. Now, we could do something. Let's do like 15 here. I don't know how long my name is. I really ought to check that, right? Well, let's do this. We could do this. Print. It is. Now there's a couple of things we can do here. There's a way to do formatted ifs, and we could do that elsewhere, where you do curly brackets here, but instead I'm going to do it slightly differently, and you'll see why that might be an issue in a minute. So we can just add them in there, right? Len, my name. Characters long. Make this short enough that that will actually get triggered. So take a look and make sure you read through this like as a human and make sure you understand what it's saying. That's my name. If my name is more than 12 in length, 12 characters long, print that's a long name you've got there. Again, these escape those characters. Print it is plus the length of my name plus the characters long. Print you should change it. If this part is false, if my name is less than 12 characters long, then it'll do this part here. Thanks for asking. Okay, so what's going to happen when I run this? Look over it. I'll give you a hint. It's going to be an error. So here it's going to tell us what the error is. It says pretty clearly, unlike some, it has to be a string, not an integer. So the problem is here, you'll remember from the very beginning when we tried to add strings and integers together, the len function gives us back a number, right? And so we can't mix in numbers, at least not this way. We can't mix in numbers with strings. Now there's another way we could do this, but for now I'm just going to typecast it. I'm going to change it from an integer to a string by putting it in there. Now, a couple of things to note here. Again, it's another function because it starts with the parentheses and ends with the parentheses, and I'm sending it a function. So it's a function within a function. These can get very, very deep. They become less and less legible, less easier to read as a human as you get functions inside of functions inside of functions. But like this way, where you just got one function inside a function, it's not too bad. And so what we're doing is we're getting the length of my name, which is going to be an integer. We're changing it back into a string, and then we're adding it into this string. And this is a small thing, but you'll note that I actually have, I have one, not the other. I have spaces here so that there's spaces on either side of that number when it gets printed. So it is 18 characters long. So now I know. You should change it. Now, I don't know what a reasonable length of a name is. Let's say that it's 20 is too long. One thing we could do is we could say, if it's more than 20, then do this. If it's less than 20, we could actually put in another statement here, else if, right? Now, there's other ways to do this. There's actually a short way in this case, if you want to, called elif, which is just a shorter way of saying else if. You can actually do both and they'll both work fine. But what we're saying is else if, and then we have to have, it's another if statement. So we could say if my name oops, nope, the length of my name is, let's say, more than 10, then that's a reasonable length. Now this is where your brain has to kind of think through the logic here. We could do and, we could have an and the length of, oops, of my, oops, is more than, say 5, or less than, we already have the more than, less than 21. Like we could do that, right? This would tell us we would only do it if both of these conditions were true. If this one was true and if this one was true. This isn't pretty common that you want to match two conditions before you're going to say it's good. But we don't need to do that second part because we already know that it's going to be, you know, it can't be more than 20, because if it was more than 20, it would have done this part here and you never would have gotten here. So we know at this point that if it's gotten to this point, it's less than 20 already. So all we're checking for is, we know it's less than 20. Is it more than 10? All right. So if it is, then we say that's a reasonable length. And let's say that if we don't like that length, again, shift to go back. Now we have the else statement and we can say print, you know, way too short. Right? So in this case, the length we know, I think we said it was 18, right? So that it's between these two, so we get this one. If it were less than 10, or if it were 10 or less rather, because we haven't done that, we can make it less than 10 by saying more than or equal to as well. We haven't hit that one before, so we will real quick. So we can say more than equal, or we could try to, more than or equal to 10, then that's a reasonable length. But if it's length of 0 to 9, then it's way too short, okay?